This is a two-limb reactor core, and let's take a look how to set up those both windings to be in series. So I took this example from a three-limb inductor. I switched a number of phases. Under the core, I choose two-limb. For windings, I copied one winding, and for the copied one, I applied this translation. So because the first winding will be positioned on the limb that crosses the y-axis, and we need just to make another one as a separate. So in assembly, as you can see, this is identical case with a gapped core, two windings. Now it's important part. Under the electromagnetics, make sure that both windings are selected as primary, and the coil group connection type is going to be connected in series. So it means that the current that will pass the one winding part will also pass another part. And now, in order to tell the software what is the current direction flowing in those two coils, we can click on terminals in order to specify which is positive and negative. And if you want to make both currents to go in opposite directions, and in this case, you can just specify the terminals in such a direction. Under the circuits, we don't need to do any changes because both windings will correspond to this one FEM coil group. And this would be like a primary winding. So here you can see primary winding. Under the waveforms, this is harmonic simulation. So I just reused the fundamental frequency. Heat was disabled in this case. So we mesh the case. Then we go to solve, simulation setup, run simulation. So, and we get results. Those losses for primary would correspond to both windings. In a newer TRAFOLO version, you will be able to see separately for each of those coils DC resistances, AC resistances, and so on. In our older TRAFOLO versions, you would only see those as a summary. Also, magnetic flux. So in this case, the magnetic flux is oriented in the same direction. So as you can see, there is no flux cancellation. So it means that both windings have the currents flowing in opposite directions.